Hello students, welcome back to the 10th board booster, that is your free crash course, and today we will be learning about electricity. I think the light is disturbing. Sir, can you just give me the thank God, I'm saved. So today we will be learning about electricity chapter where I will be covering your important topics which is related to the charges, electric current, potential energy, Ohm's law, resistance, combination of resistance, Joule's law of heating and electric power. So I will be covering every topic related to that. Also, I will be also covering the conceptual knowledge, numericals and previous year question. So what you have to do, you have to click on the link given in the description box which will redirect you to the PW application. What you have to do, you have to enroll in the free batches. After completion of this chapter, what you will be getting? You will be getting class notes and practice sheet. So please do not forget to complete all the practice so that your preparation will be absolutely fine. So let's begin. And today we are going to discuss one of the most important chapter, that is called electricity. Once you understand this topic, you will be covering the maximum portion of the kind of questions which are appearing in the examination. So you need to focus majorly on this topic, especially on the numericals and the kind of definition as well as the concepts. What exactly that we are going to cover in this chapter? These are electric charges along with the electric current, potential difference, resistance, Ohm's law, say combination of resistance. 100% the question will be appearing from this particular topic. Electric circuit, electric power and energy. This will be also giving you the confirmed question from this particular topic, and then heating effect and Joule's law. To start with the electric current, first of all we need to understand the concept of charge, because charge, the electric current is depending on charge. So we will be understanding very first topic, that is called charge. See, try to understand, if you are having a wall, the wall is made up of bricks. A single brick cannot form a wall. Likewise, electricity, which is be depending on charges, and a single charge cannot form electricity, but that is the very basic fundamental unit of the electricity. Similarly, for the charge, it is the fundamental unit or the fundamental property of matter. So that is actually required. These charges are divided into two different categories. The one is positive charge, another one is negative charge. You must have heard in the chemistry subject that the positive charge generally denoted by protons and negative charge generally denoted by electrons. So we have these positive and negative charges over here. So in physics generally we call it as positive charge, negative charge, or you can even call it as protons and electrons. No difference will be there. Talking about its property, the basic property will be, if the charges are same, like positive charge or negative charges, then in that case the charges are going to repel each other. That is the property number one, the basic property. Second will be, if the charges are unlike, positive negative or negative positive, they are going to attract. That is the very basic property that we need to write in the examination if they ask us about the property of charges. What are the other properties that are actually required to elaborate charge? The third property will be, they are additive in nature. Talking about the other properties that we need to elaborate about the properties of charge, that is, they are additive in nature, which means if we are having like few different charges at the different places in a single conductor, if we are going to add them, they can be added. We are required only the algebraic sum of those charges. For example, if I am having 3 or 4 charges, let's take an example, plus 4 coulomb, minus 7 coulomb, then again minus 2 coulomb and plus 11 coulomb. So if someone asks me like what is the value of total charge, then I'm going to add it. So this is going to be minus 9 plus 11, that is plus 2, and plus 4, that is coming out as plus 6 coulomb. So they are additive in nature. Property number 3, they are conservative in nature, which means it can neither be created nor be destroyed. So they are natural. So they can neither be created nor be destroyed. The third property is quantization. What does the quantization mean? See, if you need to calculate the amount of charges, what I'm saying, I'm repeating again, if you need to calculate the amount of charges or the number of charges, in that case, you are going to count in terms of 1, 2, 3. That means it is going to give you an integer value. there is no possibility that the charges will be in a, in a fraction like 2.5 charge. That is completely impossible. In that case, we say it is quantized, which means it is giving us some integral, the integer multiple. It is giving us the integer multiple of the number of charge, which is denoted by this formula, that is Q equals to NE. It can be represented by Q is equals to NE. I can also write it as plus minus, because if there are negative charges, I will be using negative sign. For positive charges, I will be using positive sign. So Q is nothing but, this is total charge, N is the number of charges, and this will be an integer value. This will be an integer value, and the value of E, that is 1.6 into 10 to the power minus 19 coulomb. That is the charge on an electron. If we are taking proton, it will be positive. If you are taking an electron, just consider this value with a negative sign. Where if I'm talking about N, that is nothing but plus minus 1, plus minus 2, plus minus 3, and so on. This is how it goes. This is what known as quantization of charges. So these are the major properties. Apart from that, there is one single property that I'm going to discuss. Before that, I'm going to tell you about the unit of charge. So the unit of charge will be coulomb. So it is represented by, the unit of charge will be coulomb. The last property which I need to discuss, that the force is directly proportional. You can consider is that property number 5. So force will be directly proportional to the multiplication of two charges. If I'm considering there are two charges, Q1 and Q2, then it will be the multiplication of both the charges, and it will be inversely proportional to the square of the distance between them. So on combining both the equations, I will be getting F is proportional to Q1 Q2 by R square, and if I'm going to remove this proportionality sign, I will be getting a constant K. So that is K Q1 Q2 by R square. That is the formula, you can say, or it is providing us the amount of force or the value of force through which the two charges are feeling attraction or repulsion if they are separated at some distance R square. This is also representing the inverse square law, because the denominator will be in the form of square. So these are the basic things that we need to understand before we proceed towards the electric current. So let's talk about the electric current. So electric current is the rate of flow of positive charges. Current is rate of flow of positive charges. Whenever it is saying the rate of flow of charges, when the rate is coming out, that means it is related to the time. The amount of charges or the number of charges flowing in whatever time interval, that is defined by the electric current, which clearly says if the current representation is I, so current is represented by I, so the rate of flow of charges, the formula will be I is equals to Q by T. In at what time or in how much duration of the time, what value of charges or the what amount of charges are going to flow through any conductor, that is called electric current. So talking about the direction, so if we are having any conductor, if the electrons are flowing in this particular direction, then we say that the electric current will be in the opposite direction. We need to understand the direction of electric current will be opposite to the direction of flow of electrons. So this is how it will be represented. So opposite to the flow of electrons, when we talk about its unit. So to elaborate this, we are also having like coulomb per second, which was given by ampere. So it can directly represented by ampere. Talking about the other popular unit, because if you are provided with milliampere, then you need to convert it into 10 to the power minus 3, and if you are provided with microampere, then you need to put 10 to the power minus 6 to convert it into its SI unit. Have a look about this question. So how we can proceed with this question? So we are provided with an electric source can supply a charge of 500 coulomb. So the very first thing that we need to write, that is the given value. So I'm going to write the value of Q is given as 500 coulomb. If the current drawn by the device is 25 milliampere, find the time in which the electric source will be discharged completely. So we are provided with electric current that is 25 milliampere, and they are asking us about the timing, how much time it is going to take. In that case, so we need to write down the formula, but before that we need to completely understand, are they providing us the correct unit? So we need to convert 25 milliampere as 25 times 10 to the power minus 3 ampere. Now I am going to use the values. The formula for the electric current is I is equals to Q by T. From here I can also write it as T is equals to Q by I. So the value of Q given as 500 coulomb, and the value of I that I am having, that is 25 times 10 to the power minus 3. So simple mathematics, like this is going to be 10 to the power 3 divided by 25. If I am going to cancel this, I will be getting 20, and finally the value is coming out as 1, 2, 3, 4. This much of seconds required. So when we look into the option, so option number D will be the right answer. After covering all this, we need to understand what is potential difference. So when we talk about the potential difference, it is represented by V. See, the charges are moving from one place to another, but some work is actually required to be done so as the charges are moving from one place to another. Potential difference defines the same thing. It says the potential difference between 2 points is the amount of work done in moving a unit charge 1 coulomb from one point to another. So if the charge is moving from A to this point, that means it is doing some certain amount of work. So in that case, the potential difference will be represented as the amount of work done on charge will be representing the potential difference. Generally, when we talk about about the flow of electric current, when there is a potential difference, we generally say the current is flowing from the higher potential to the lower potential of the battery. But what exactly is going to be happen? The charges are moving from one point to another, and the amount of work done is actually required to be done to move the charge from one place to another, which is also represented by this particular formula, that is V equals to W by Q. So it is represented by V and its unit is volt. The unit of work done is joule, charge is coulomb, we already know that. But the SI unit of potential difference will be capital V, that is volt. Moving further, so they're asking like define the term potential difference. This question been asked in 2025. So define the term potential difference between the 2 points in the electric circuit carrying current. Name and define the SI unit, also express it in the SI unit of work and charge. So in the previous slide, exactly this is what I discussed. So what we are going to write, the amount of work done to move a charge from one place to another, that is called the potential difference, that is called the definition. So in definition, that we are going to write the amount of work done. Then they are asking about the name and define the SI unit. So define its unit. Unit will be volts represented by capital V, and express in terms of SI unit with the work and charge, that is joule and coulomb. This is how you need to write the answer. In the previous slide I have already explained. Moving ahead to the next question, we are provided with this question. They are asking calculate the amount of work done by a cell when 20 coulomb of charge is moved through a potential difference of 3 volt. So what do we have to do? We have to first write down the given values, then we are proceeding with the solution. So in terms of the given value, we are provided with the charge. So the charge given as 20 coulomb charge is moved through a potential difference, that is 3 volt, and what we have to calculate, the amount of work done. To elaborate this, I need to put the value in the given formula, that is V equals to W by Q. If I am going to put the value, that is 3, potential difference, sorry, the value of V is 3 here, correct? And the value of W that I need to calculate, and the value of Q is given as 20. So the value of W is nothing but 60 joules. If we look into the options, so we are provided with these options, and option number C will be the correct answer. Moving ahead, why current flows and what is the potential difference related to this. So now here comes the concept. When there is a potential difference, just consider we are having a battery over here with the positive and negative terminal of the battery. The conductor is connected over here, and the electron is actually flowing from the lower potential to the higher potential. So the electrons are actually moving in this direction. So if I'm going to mention there are electrons in the conductor, so potential difference will be providing some sort of force which is actually providing the flow of electrons in this particular direction. As a result, the electric current is moving in this particular direction, which is also known as this is called electric current. And if the electrons are moving from negative terminal to the positive terminal, that is called the conventional current. So according to the statement, electrons flow from lower potential to higher potential, and the current actually flows from higher potential to lower potential of the battery. This is how, but the circuit need to be closed, otherwise the current is not going to flow from one end to the another end. So talking about the symbol, so if we talk about the symbol of a battery, so it will be represented by a long bar and a vertical short bar. So the vertical long bar will be positive terminal and the smaller one will be the negative terminal. That is called a battery. This is called as battery. Whereas if there is a combination of cells, like this, then it is called as battery. So in that case, I need to put the symbols positive, negative, positive, negative, positive, negative, and positive, negative. So for example, if each battery having a value of 2 volt, so 2 volt, 2 volt, 2 volt, and 2 volt will combinedly will become 8 volts. So if the sequence is positive, negative, positive, negative, positive, negative, then it is going to add each other. But what if I'm going to change the sign? So if I consider like here is positive, negative, here is positive, negative, so they are having the opposite sign, so they will be cancelling each other, and the value in that case will be 2 volt and 2 volt. So they are going to cancel their potential because they are providing the opposite flow, so it will be 4 volt. Otherwise, if I'm going to put the correct symbols, then it is going to be 8 volt. If the value of each cell is 2 volt, then it is going to be added. Moving further, so there is a question given to us that is assertion and reason based, asked in 2024. So this question says electrons move from lower potential to the higher potential in the conductor. So this is what in the previous slide that we have seen, the electrons were actually moving from lower to higher potential. So this statement seems as true, whereas in the reason they say the dry cell maintains electric potential difference across the ends of the conductor. The answer is yes, because it was actually maintaining the potential difference. The potential difference, how it is actually maintained, we need to consider an example. For example, like we are looking into a dam and the water is flowing from the higher channel to the bottom of the canal through which it is going to pass. So there is a difference, there is a change in flow that you can see. The water can be allowed. So the battery or a cell that is providing that potential difference which allows the electric current to flow or the electrons to flow from one end to the another end. This difference allowed the electrons to move. As a result, the electric current is going to flow. That is the reason the electric current flows through it. So this is what they are asking, that the electric cell maintains electric potential difference across the ends of the conductor. So that is also true. So if the assertion and reason both are true, then the option will be A. That is the correct answer. This is how you need to proceed. You need to understand the concept and you can write down the answer accordingly. Now we need to understand Ohm's law. What is an Ohm's law? That is very, very important, and the basic questions will be solved from that particular topic, as well as examiner might be going to ask some 1 or 2 marker question where they are going to ask about the definition, the properties, maybe the graph. So we need to understand this minutely. So according to this, the potential difference V across the ends of the metallic conductor is directly proportional to the current flow through it, provided its temperature remains same. What does that mean? It means that if we are having a potential difference V, so it is directly proportional to the amount of electric current flowing through it, and where the temperature will remain same. There should not be any temperature difference when you are looking into this Ohm's law. So let me give you an example. If you are having a small cell, which we generally use in a remote or torch, so it is providing the small amount of current. Whereas if I'm talking about the car battery, it is providing the more value of current. Similarly, in the inverter battery, it is providing the high value of current. So as soon as if you are increasing the value of potential difference, the amount of current will be on the higher side. So they are proportional or directly proportional to each other. Once changing the value, the other will be changing the value. Vice versa is also true if the value of current is increasing, which clearly states that the potential is already been increased. Apart from that, if I'm going to remove the proportionality sign from this particular one, I will be getting a constant, that is R. This is called constant, and this constant is known as resistance. The name of this constant is resistance. That is one of the important topic that we need to look into, that is resistance, and this comes from here. When we talk about this, the potential difference is provided across this terminal. So let's draw the circuit. So this electric conductor or the conductor provided with connection. Now this is positive and negative, and the electric current is flowing through it. So what is going to be happen? The charges will be moving, or the electric current is moving, but it is having some sort of the resistance value which is actually stopping the electric current to flow through that conductor. So that depends upon the material also, what kind of material it is. Are you using a copper, silver, or iron or aluminium? So that the value of resistance will be depending on the material what you are using as a conductor and the amount of flow of current. So in that case, if we look into the VI graph, that is the potential difference versus electric current graph, related to this, we can clearly see that this value is actually giving you the value of resistance. This, how we can calculate the value of resistance through this? What we have to do, we have to calculate, or we can mark the values of electric current and potential difference like this. Let's consider this is 5, this is 10, and this is 1, and this is 2, because this is giving a slope, perfect 45-degree slope. So in that case, if we are going to put the value to get the value of R, what we are going to get according to this, R is equals to V upon I. So in case number 1, if I am going to put the value, I will be getting 5 upon 1, that is 5. So the value of resistance is 5. Similarly, if I am going to put the same value over here, I will be getting 10 by 2, which is again giving me the value as 5, which means the value of resistance is same. The amount of potential difference being increased as well as the amount of electric current increased because of the Ohm's law. Now if we understand talking about this, so it says the slope actually giving the value of resistance. What we actually did, we applied this V upon R, which is also perpendicular by base, which is nothing but tan theta. So tan theta represents slope. So the slope related to tan theta, the formula is perpendicular by base. Perpendicular by base is nothing but, according to this graph, that is V upon I, which is giving us the value of resistance. So if you are having such kind of graph, V versus I graph, this particular line, if you are having a slope, you can exactly calculate the value of resistance through this. Whereas I'm having like 3 different values or 3 different graphs, which is VI graph, this is R1, this is R2, this is R3. So if they ask you to compare which one is greater, so it will be very easy to elaborate. More will be the slope, more will be the resistance. So now look at the slope. So we are having this slope will be having the higher value. So R3 will be having the highest resistance. Then we are having R1, and at last we are having R2. So this will be the sequence of the resistance or the value of resistance in a decreasing order. So R3 will be the highest, then R1, then R2. This is how you can calculate the value of resistance. Now let's talk about the same thing that which is provided, but here the graph is actually reversed. They are asking us about the current versus potential difference. Previously they were giving us VI graph. Now we are having IV graph. In that case, if we are going to calculate the value of slope, the slope will be calculated as 1 by R, because they have changed the axis. I on the x-axis we are having V instead of I, on the y-axis we are having I instead of V. So the value is going to be reversed. The slope will be giving you the value of 1 by R. So in the question paper you need to put minute attention whether the graph is given for VI graph or IV graph. For the VI graph, the slope will be giving you the value of resistance as R, whereas if you are having IV graph, then you will be getting the value of 1 by R. So if you need to calculate, you need to reciprocate it. Moving further, talking about the resistance, what the resistance is. Resistance means any conductor is which is comprising of the resistive property, then it says resistance means to try to stop or tend to stop. So it is actually trying to stop the flow of current. I earlier mentioned that the electric current which is flowing through the conductor, which is passing, I have earlier mentioned the electric current is flowing through the conductor depending upon the material. So every material having their own property. So if the current is flowing through this conductor, because of the property of the material, the current will be stopped by the resistance because of its its own property. Because of that, so the resistance is the property of a conductor to oppose the flow of electric current. It means very simple. It says like on what factors, that is one of the another question which is generally been asked, on what factors the value of resistance will be depending on. So the value of resistance depending on the length of the conductor, area of the conductor, and it will be giving you the resistivity, that is represented by rho, that is depending on the property of the material and depending on the temperature. But before that we need to understand the unit of resistance is ohm, represented by this symbol ohm. So as I mentioned, on what factors it has been depended on. So let's have a look. So resistance is directly proportional to the length of the conductor, as they mentioned, whereas the resistance is also inversely proportional to the area of the conductor. If I consider these are the two equations, on combining I will be getting R proportional to L by A. So if I'm going to remove the proportionality sign, I must be getting some constant, and that constant is nothing but rho. That is called the resistivity. This constant is called resistivity of the conductor. It is depending upon the material. So this is a constant known as resistivity. So we'll discuss further about this. So talking about the other values, as I already mentioned, the unit is ohm represented by R. SI unit of resistivity. To understand this, I need to write down the formula once again. So I have provided, that is R equals to L by A. So if I'm going to cross multiply, so I will be getting rho is equals to RA by L. Now put the values. The value of the unit of resistance is ohm. Area will be represented by an SI unit meter square, and the length will be represented by M. If I'm going to cancel, the unit that I'm going to obtain, that is ohm meters. So this is ohm meters. Look at this diagram. So it is clearly mentioning that these are the the blue or the purple circle which is moving as a free electrons. The free electrons are actually traveling, but these are the material property. Then the red spot which is actually trying the electric current or the electrons to flow through them, that is called the resistance. That is depending, again I'm mentioning, it is clearly depending upon the material how it is going to be. Then later it comes as the length and area. Moving further, we are having one question. It says the resistance of wire does not depend on on what factor it does not depend on. So it says length, so it depends on area, it actually depends. Shape, so in the previous diagram it was clearly mentioned the area. So if this is circular, we need to calculate the area of circle, that is pi r square. So it is also depending upon the shape, material. So resistance does not depend upon the material. That is the resistivity which is depending on material, due to which the resistance need to be indirectly depending on the material, because we need to put the value of resistivity whenever we are using any material, and based on the material that particular value will be fixed. So the answer will be material. So the resistance which is does not depending on something, that is material. Moving further, so they're asking about, write down the relation between resistance and electrical resistivity of the material of the conductor in the shape of cylinder of length L and area of cross section A, and hence derive the SI unit of electrical resistivity. So it is just like the basic that we have studied. So according to this, the value of R is equals to rho L by A. So that is the formula. And they're talking about the SI unit of the electrical resistivity. So the unit of electrical resistivity, that is ohm meters. This is what you need to write in such question. And this question been asked like 3 times in the consecutive years. Talking about the resistivity, what resistivity is? So it is the property of the material. It does not change with the shape and size of the material. So it is the inside own property depending upon the kind of material it has been made. It does not depend on length, area, diameter, radius. It is the resistivity order, if we talk about, it is very less in metals than in alloys and highest in insulators. So it is having an order. So if we are going to use metals, that is silver and copper, the value of resistivity will be low, and which is actually making the wire as a very good, the conductor. Copper and aluminum are used for transmission lines. That is an informative, because sometimes the multiple choice question been asked in the examination based on that. So as for the transmission line, generally we are using copper and aluminum. Insulators like rubber and glass have high resistivity, that is poor conductors. So why they are poor conductors? Again, because the resistivity value is on the higher side, which does not allow the electric current at all to flow from one end to the another end. So used as insulator. SI unit that we have already mentioned, that is ohm meters. Talking about the resistivity, so we are provided with some value. So let's consider we are having 3 different values. To solve this, we need to understand the kind of value which is giving to us. For example, we are having 3 different materials and they are asking what metals or what material it is, but the value of resistivity being given to us, that is 10 to the power 17, that is 44 into 10 to the power minus 6 and 1.62 into 10 to the power minus 8. So if we look into this, the value of resistivity is very, very high in the case number 1, which clearly states that this is nothing but an insulator. So the material A is nothing but an insulator. Whereas we are having an order of 10 to the power minus 6 and 10 to the power minus 8. In that case, this B is alloy, whereas it is having a very less, so it comes under the category of metal. This is how we can understand the value or what kind of material being given to us. Moving ahead, talking about the resistivity, so we need to if we need to calculate the value of potential difference, we are provided with this instrument that is called voltmeter. Generally, it says the value of resistance is very high in the voltmeter connected in parallel. Parallel combination. I'm going to discuss about the series and parallel combination later on, but connected in parallel across resistance. So we would be able to get the value that what is the potential difference across any conductor or any resistance. So voltmeter will be responsible for that. Whereas talking about the amount of current, so this is how the ammeter look like. So in that case, the value of resistance R is very low, so which allows the electric current to flow through the ammeter. As a result, we get the value, and as well as, so it is connected in series with resistance. So this is how we do the combination of or the connection of voltmeter and ammeter. Moving ahead, we are provided with one question and it says the resistance of metal wire of length 3 meter is 60 ohm. Let's write down the given values and then we will proceed. So we are given with metal wire of length 3 meters and its resistance given as 60 ohm. Now it says if the area of cross section of the wire, so we are given with area of cross section that is given as 4 times 10 to the power minus 7 meter square. We need to calculate the value of electrical resistivity. Next, how will the resistivity of the wire change if the length and diameter of the wire both are doubled? Justify your answer. So one by one we are going to calculate the value. So we need to calculate the value of resistivity. I am going to use R is equals to rho L by A, through which it is going to be RA by L. All the values are given in a SI unit. So I am going directly all the values. So this is going to be 60. The value of current given as 4 times 10 to the power minus 7. The length of the conductor given as 3. So we have put all the values. Let's cancel out. We will be getting 20 over here. Resistivity is coming out as 8 into 10 to the power minus 6 ohm meter. This will be the final value for the electrical resistivity. Now they are saying how will the resistivity of the wire change if length and diameter. See, if length is going to be twice, if diameter is going to be double, there will be no change in resistivity. No change in resistivity. They're asking, justify your answer. So what you are going to write in that case? So write down the bold letters that resistivity depends on material, does not depend on length or area or diameter. So this is how you can justify your answer. Moving, so just try to remember, like, resistance depending on length and area, resistivity depending on material. Now we are provided with another question. It says in the following figure, 3 cylindrical conductors A, B and C shown in the figure along with their length and area, if they are made of same material, calculate the value of RA by RB. This is what they are asking. So we need to calculate the value of resistance one by one and then we need to calculate the ratio of all of them. So let's begin. So we are given with this. So for the first one, for RA, that is going to be rho L by A. Let's consider this value as R. For B, I'm putting the value that is rho. The value of L is given as L by 2 and the area is given as twice of A. So I will be getting rho L by 4A. But rho L by A I have considered as R, so I can write it as R by 4. Talking about the third one, so it says the length is half and area is also half. So third one is rho L by 2 and this is A by 2. So this is going to cancel out each other, which is coming out as R again. Now I have to calculate RA by RB. So I only need to put the value to get the ratio. So the first one, very first one, that is RA by RB. What are the values? The value of RA is R and the RB is R by 4, which is coming out as, on cancelling, I will be getting ratio as 4 by 1. Whereas for RA by RC, so for second one, that is RA over RC, the value of RA given as R, the value of RC is also R, so the ratio is nothing but 1 by 1. You can also write it as in the ratio 1 by 1. That's how such kind of question can be solved. Moving ahead to the another question. So it says a wire of given material having length L and area of cross section A has a resistance of 4 ohm. So if this is the conductor and the value of resistance given as 4 ohm for this one, find the resistance of another wire of same material having length L by 2 and area of cross section 2L. Fine. So we need to calculate the value of both the resistance. So I am having RA, that is rho L by A, and this value is equals to 4 ohm. Talking about the second one, that is RB. So that is rho, the length given as L by 2 and area given as 2A. So which is coming out as rho L by A 1 by 4. So this value is equal to RA. So I have got RA by 4. If this value is 4, the answer will be 1 ohm. So they are going to provide us, or they are going to giving us the value of resistance, and then they are altering the value of length and area. In this manner we would be able to solve the numericals. So moving ahead to the next question. So it says a resistance of wire 0.01 centimeter radius is 10 ohm. If the resistivity of the wire is 50 into 10 to the power minus 8 ohm meter, find the length of the wire. To get this, we need to write first of all the given values that are provided. So the resistance of wire of length 0.1 centimeter, or the resistance of wire of 0.01 centimeter radius. So we are given with radius, that is 0.01 centimeter. First of all, we need to convert it into meters. So I'm going to write 0.01 into 10 to the power minus 2 meters, which can also be, if I'm going to remove this, I will be getting 100, and which is coming out as 10 to the power minus 4 meters. The value of resistance also given, that is 10 ohms. It says if the resistivity of the wire is 50 into 10 to the power minus 8 ohm meters, so the unit is an SI, find the length of this wire. We need to calculate the value of length. We only need to put the formula and only need to apply the formula, and also we need to put the value. Let's see how it works. So R is equals to rho L by A. So the value of R is 10. The value of resistivity is 50 into 10 to the power minus 8. The value of length that we need to calculate, area. See, if they are providing us the radius, then definitely the wire is nothing but a circular wire. In that case, I will be putting the value as pi r square, that is 10 to the power minus 4 to the square. So this is 10 equals to 50 into 10 to the power minus 8 into minus 8 times L divided by pi into 10 to the power minus 8. So if I am going to cancel this, 10 to the power minus 8, 10 to the power minus 8 going to cancel out. Now L is equals to 10 times pi divided by 50. So 0 and 0 will be cancelling out each other. So this is 3.14 divided by 5. Although you can leave it at that particular state, otherwise you can, if you are going to divide it, you will be getting somewhere around 0.62 meters. So that will be your final answer for this question. So just follow the steps. What new thing that we have seen in this, the area given, and there are in the area we need to put the value of R, which means if radius is given or diameter being given, we need to consider that the conductor is nothing but a circular in shape. The next question is, how much does the resistance change if the diameter of wire is doubled? Okay, so resistance is inversely proportional to the area. So let's create the relation. So that is 1 by pi r square. So if they are giving us diameter, so diameter is how much for the radius? Radius, that is d by 2 whole square. That is radius, that is the relation. Like the half of the diameter is nothing but radius. So if R is related to A, in that case the new resistance which is going to be R by 4. So this is how, if you are going to square this, you will be getting d square by 4. So the relation will be in terms of r by 4. The next question is, a copper wire has a diameter of 0.2 mm. So we are provided with a diameter that is 0.2 mm. I need to correct the unit, that is 0.2 into 10 to the power minus 3 meters. If you want it, you can take it as diameter or you can convert it into radius. That is also possible. So first of all, I'm going to remove this. I will be getting 2 times 10 to the power minus 4 meter. I'm making it as radius. So 2 times 10 to the power minus 4 divided by 2 meters. So finally the value of radius is 10 to the power minus 4 meters. Resistivity given as, resistivity given as rho equals to, that is 1.6 into 10 to the power minus 8 ohm meters. What will be the length of this wire to make its resistance 14 ohm? So we need to calculate the value of length, the value of resistance given as 14 ohm. How much does the resistance change if the diameter of the wire is doubled? So diameter, they are going to increase the value of diameter. First of all, we need to calculate the value of length. So let's do it. So R is equals to rho L by A and L is equals to RA by rho. Let's put the value. So the value of R is 14. Area will be pi R square. So the value of R is 10 to the power minus 4 into 10 to the power minus 4 divided by resistivity, which is 10 to the power minus 6 into 10 to the power minus 8. So this is going to cancel out. And we are having 14 into 3.14 divided by 1.6. So the value of L will be, that is your homework. So you have to write down in the comment box what will be the value of length and what is going to be happen if the diameter of the wire is going to be doubled. So I'm clearly mentioning here that this will be your homework and you have to write in the comment box the answer of this question. Now proceeding towards the next question, which says the potential difference across the two ends of the circuit component is decreased to 1/3 of its initial value while its resistance remains constant. What change you will observe in the current flowing through it? Name and state the law that helps us to answer this particular question. So the thing is, they are actually mentioning that the potential difference is actually decreased by 1/3. So this is the potential difference. So in that case, the value of current will also be I by 3. The reason is the resistance is already constant and V is directly proportional to R, and this is defined by Ohm's law. So the complete answer will be like that. So we need to write the relation, and finally that is the reason why this is coming out. Moving ahead, we need to find the combination of resistance. So there are two types of combination. First is series, then second we have parallel. So in that case, consider we are having three different resistors, that is R1, R2, R3. If the resistors are connected back to back from each other, from the tail of the first resistance, head of the second resistance being connected, then it is called a series sequence. So in that case, if I'm going to complete the circuit, for example, if I'm completing the circuit, I have connected a battery over here. I'm putting the value AB. This is positive and negative. So what I have to do, the positive terminal to the negative terminal defines the direction of flow of current. So this is the direction of flow of current through this. So if we look very closely, the current is flowing through R1, R2, R3 and the same amount of current is flowing through this. So in the series combination, what we have observed, the current through all the resistors will remain same. Whereas the potential difference across this will be V1, the second will be V2 and third will be V3, and the sum of all the three resistors will be equal to the potential difference which we have applied over here. So here the potential difference will be different. We need to calculate the equivalent resistance, which means if we are going to remove like whatever number of resistors being given to us, if we have to replace it with 1, how we can calculate the value of equivalent resistance across these two terminals AB. In that case, we are going to use this relation that we have acquired so far, which says V is equals to V1 plus V2 plus V3. That is the individual potential difference which is coming across all individual resistors. According to the Ohm's law, we know the value of V, that is, according to Ohm's law, that is V equal to IR. Here R will be giving us the equivalent value in terms of series. For V1 it is going to be, because the current is same, so that is I, but across R1, similarly I across R2 and the same current I across R3. I can see that the I is common in all three terms. I will be taking out as common. I will be getting R1 plus R2 plus R3. So both the currents will get cancelled out and the equivalent resistance Re or Rs will be equal to the algebraic sum of individual resistors, and this is how you calculate the equivalent resistance across any conductor if they are given in series. So it is nothing but the algebraic sum. If there are n number of resistors being connected of equal values, in that case R will be equals to n times of R. That is, in series combination it will be applicable if n number of resistors of each R ohm value, then equivalent resistance, I'm talking about series. If m number of resistors are connected in series, all are having R value, then the equivalent resistance which is coming out as Rs equals to, or R equivalent equals to n into R. So this will be giving us R1 plus R2 plus R3. Quite easy to understand. Similarly, when we talk about parallel, so parallel means the potential difference across all the resistors that we have will be having the same potential. So let's consider if I'm having a battery which is connected through this, the I amount of current which is coming across this terminal. So because we are having three different paths over here, this and this, the current is going to be distributed, naming it as I1, I2 and I3. So we have noticed the current will be different in the parallel condition. The current will be different in the parallel condition, but potential across all three resistors is nothing but AB. A and A for all three, and similarly the B and B for all three. So potential difference will be same. It is exactly opposite to the combination of resistance that we have seen in the series combination. So that will be in the series combination the current was same and potential difference was different, whereas in parallel current will be different and potential difference will be same. How to proceed or how to find the equivalent resistance in that case, I will be again using the result. So what distribution that we have seen in the parallel combination, that is I is equals to I1 plus I2 plus I3, and according to Ohm's law we know that V by R equivalent, that is equals to, what will happen for R1? So we have seen I will be equals to V by R1. For I2 it is going to be V by R2. For I3 it is going to be V by R3. If I take V as a common on the other side, so this is V by R equivalent, V as common, I will be getting 1 by R1 plus 1 by R2 plus 1 by R3. V and V will get cancelled out, and finally what we have obtained, that 1 by R equivalent, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3. See, we need to remember, if you are finding the value of R equivalent in the parallel combination, by doing all the calculation, you need to reciprocate this value, because this is giving 1 by R equivalent. But we need to calculate R equivalent, so whatever value you are getting, you need to reciprocate it. Second thing, if I'm going to correct, if n number of resistors of R ohm connected in parallel, then in this condition the value of R equivalent will be R by N. This will be the value. If you can recall, in the series combination I had given that R equivalent was N into R. Here I will be getting R by N. So it also provides us a very important thing. Whatever the equivalent you are finding in series combination will be greater than the individual value of the resistors. Whereas in the parallel combination, the R equivalent will be smaller than the smallest of all the resistors that we are having. So for example, it is having 1 ohm, 2 ohm, 3 ohm. If I am going to calculate the R equivalent, the answer will be less than 1 ohm, which was the smaller resistor in this combination. So parallel combination will be giving you the smaller value. Fine. Moving ahead, so we need to calculate the value of equivalent resistance in such condition. So let's proceed. So we can see that the current has been divided if it is finding across XY. So let's consider the two currents being divided, I1 and I2 over here. So it is a parallel combination. It is what? It is a parallel combination. So for the parallel combination, I need to put the formula which says 1 by R equivalent is equals to 1 by R1 plus 1 by R2. On putting the value, I will be getting 1 by 3 plus 1 by 6. Let's take LCM. I will be getting 6, so which is coming out as 2 plus 1. So 1 by R equivalent is coming out as 3 by 6. On cancelling, I will be getting 1 by 2. I need to reciprocate this. Final step will be, so R equivalent will be coming out as 2 ohm. As I mentioned on the last slide, the value will be smaller than the smallest resistor in the circuit. So we are having 3 ohm, which is provided, and the final equivalent is smaller than 3 ohm, that is 2 ohm. Again, we are having another circuit, but here if we analyze this, we need to calculate, or we need to evaluate the flow of electric current. So over here, if the current is I flowing through this, it will be divided through this junction, which is coming as I1 and I2. Yes. Now the I1 will be flowing through this 4 ohm resistor reaching at this particular junction, and I2 will be flowing through this 12 ohm in that manner and will be reaching to the same junction. And after all this travel, it will be again combining it as I. That means the same current is flowing through 3 ohm. So what we have to do, so if we see the current is distributed among these two resistors, so these two 4 ohm and 12 ohm will be parallel to each other. After solving this, we will be having this 3 ohm in series. Let's calculate. To get this R equivalent, so formula will be 1 by R equivalent will be 1 by R1 plus 1 by R2. So that is coming out as 1 by 4 plus 1 by 12. If I take LCM, it will be 12. For this, it is coming out as 3. It will be 1, which is coming out as 4 by 12, 1 by 3. And on doing the reciprocal, I will be getting R equivalent as 3 ohm. So the value of R equivalent is coming out as 3 ohm for this parallel combination. Now the circuit will be looking like that. There will be a resistor for the parallel one. So which is equal to 3 ohm, and this is 3 ohm given, and this junction is X and this is Y. So the final answer that I am going to get, that will be R1 plus R2, because 3 ohm and 3 ohm both are in series, and I need to add this, so which is 3 plus 3 coming out as 6 ohm. That will be the final answer. Instead, if you want to take this as a step, you can, but the final answer will be 6 ohm. This is how we solve the combination of resistance, the basic initial starting of the series and parallel combination. We have another question which says find the equivalent resistance between X and Y. So over here, if the current is divided, so I am considering I1 and I2. So I2 will be flowing through 16 ohm, reaching over here, I2, whereas I1 will be flowing through this 8 ohm and 8 ohm, which means these two are in series combination. So let's do this. So the final that we are going to get the circuit as this will be 16 ohm, this will be 8 plus 8, 16 ohm, this is Y and this is X. There are two ways of solving such questions. We are having 16 ohm and 16 ohm, the values are same. There are two number of resistors, so our equivalent will be R by N. According to this, R by 2, answer should be 8 ohm. But we'll do the conventional method for now, because in the examination you have to solve in such manner. So 1 by R1 plus 1 by R2, this is 1 by 16 plus 1 by 16. On taking LCM, I will be getting 2 by 16, giving us R equivalent as 8 ohms. So this will be the final answer for this kind of circuit. On proceeding, they are again asking the equivalent resistance between A and B. So where is A? There is B. That means the current is flowing from A to B. So in that case, I need to provide the flow of electric current. So the current I is flowing through R1 divided in R2 and R3, and then again combined at R4. So first of all, I will be solving the parallel combination of R2 and R3. Again, these are the two same values, so that means 10 by 2, 5 ohm should be there. There is another method. If they are providing you the question in the terms of MCQ, if you need to calculate the parallel combination of two resistors, you can even do like that. Like for the R parallel, that means R1 R2 by R1 plus R2. In that case, if I am going to put the value which is 10 multiplied 10, that divided by 20, so this is providing us 5 ohm. So finally on solving this, I will be getting, this is 5 ohm. The parallel combination came out as 5 ohm, and the R4 is also given as 5 ohm. So now the equivalent resistance across A and B is 5 plus 5 plus 5, which is coming out as 15 ohms. So that is the another method of solving fast such kind of numericals. Now another interesting question. Now they have changed the shape of the diagram or the circuit which is provided to us. Now they are asking about the equivalent resistance across XY. What we have to do, we have to do the same process. In that case, the current will be divided from here. The I1 will be flowing in this direction and I2 will be flowing through this direction, and they have to reach to the terminal Y. So I1 will be flowing through 4 ohm, then towards 2 ohm, meeting over here, and I2 will be flowing through 2 ohm and 10 ohm, reaching at this junction, which means if I1 is flowing through 4 and 6, Y and X. So 4 and 2, that is coming out as 6 ohm, 2 and 10 will be coming out as 12 ohm because they are in series. Now calculate the parallel combination. So R equivalent, that is equals to R1 R2 by R1 plus R2, which will be giving us 6 multiplied 10 divided by 18. So this is going 3 times, this is going 4 times. So the value of R equivalent is nothing but 4 ohm. This is how you can solve such kind of questions. Now another question being given, determine the equivalent resistance of the combination between ends A and B. So first of all, we need to understand where are the terminals A and B. So here we have terminal A, here we have terminal B, which means if the current is coming through terminal A, it will be dividing into I1 and I2 will be dividing over here, and the I1 will be flowing through 2 ohm only here, and I2 will be flowing through this 2 ohm, 2 ohm and 2 ohm reaching at this terminal. So finally the circuit will be like this is 2 ohm and the rest 3 will be considered in series, 2 ohm, 2 ohm and 2 ohm, which will be 6 ohm. So this is terminal A, terminal B, and the R equivalent will be R1 R2 by R1 plus R2. Let's put the value, that is 2 multiply 6 divided by 8. So this is 4, this is 3 and 2. So finally the R equivalent is 3 by 2, which is equals to 1.5 ohms. So please try to understand the importance of the terminal or the R equivalent across what terminals it is going to be asked. So accordingly you have to apply the flow of current. Now we have another combination, that is they are again asking the equivalent resistance of the combination across A and B. So here is A, we have B. Again we have to distribute the value of current. So we are having I1 over here, I2 across 15 ohm and I3 across this path. So I1 will be flowing from 6 ohm and 4 ohm. I2 will be flowing alone across 15 ohm and I3 will be flowing through 3 ohm and 3 ohm. So equivalent or the kind of circuit which can be appear. So this is 1, this is 2, this is 3. So 6 and 4, which is coming out as 10 ohm, second one was 15 ohm, and this is 3 and 3, 6 ohm. Now there are two ways of solving. Either you can apply R1 R2 upon R1 plus R2 with 10 and 15, whatever is coming out, you can again the same process with the third one. Else conventional method that we are having according to the formula, 1 by R equivalent, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Let's put the value. I will be getting 1 by 10 plus 1 by 15 plus 1 by 6. The LCM will be coming out as 30. So this will be giving us 3 plus 2 plus 5. So 1 by R equivalent, that is 10 by 30. On cancelling, R equivalent value is nothing but 3 ohms. If you are applying the correct concept, the flow of current, the potential difference, then definitely you will be getting the right answer in that case. So it says the important note, resistance across parallel will be less than in series, because if we calculate this, we will be getting R series as 6 plus 3, that is 9 ohms, whereas in this combination R parallel we will be getting R1 R2 by R1 plus R2. If we calculate this, we will be getting 6 multiply 3 divided by 9, 2. So we are getting 2 ohm. So of course in the series combination we will be getting the greater value. In the parallel combination with the same resistors we will be getting the smaller value. So that is note number 1. So the next question, it says the maximum minimum resistance which can be made using 4 resistors each of 4 ohm. This question been asked 3 times. Now they are saying the maximum and minimum value of the resistance. So there was one thing that I earlier mentioned, that if you want to get the maximum value in the previous note that I gave you, the maximum value that you can be obtained if the resistors are connected in series. But if they are connected in parallel, you will be getting the minimum value. So there are 2 things, 1, 2, 3, 4. So consider it as AB. The value of each resistors, I am writing it as 4 ohm. This is the first combination, and second combination where we will be getting the minimum value. In that case, all 4 resistors will be connected in parallel. Terminal B, terminal A, this is 4 ohm, 4 ohm, 4 ohm and 4 ohm. Now we have to calculate the value of equivalent resistance. So in series combination, that will be R1 plus R2 plus R3 plus R4. Correct. Put the value 4 plus 4 plus 4 plus 4, which is giving us as 16 ohm. For the parallel combination, 1 by R parallel, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. On putting the value, I will be getting 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. By taking LCM, I will be getting 4 by 4 and finally the answer will be 1 ohm. So we can clearly mention that this is giving us the maximum value and this will be giving us the minimum value that we can acquire if the same value of resistors are connected in series and parallel. On moving ahead, the important notes can be like if they are having the same, I already told you that RS will be equals to 3R. Similarly, in this case, it will be R by 3. Got it? Now, another question, being given a piece of wire of resistance R is cut lengthwise into 3 identical parts. Now, the length has been cut in 3 different parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the value of R by R dash is. So, to proceed this question, what we have to do, first of all, let's consider a wire. So, I'm having a wire over here. The value of resistor was R. Now it is divided in 3 different segments, which will be divided R by 3. What exactly has happened? So the length has been, the wire has been cut in 3 identical parts. The length has been divided 1/3. Because the R is directly proportional to the length was actually divided 1/3. So the new resistance of that individual segment of that will be considered as R by 3. Now these parts connected in parallel. So what exactly has happened? They are connecting these 3 resistors in parallel combination. So this is coming out as R by 3, R by 3 and R by 3. Now we have to calculate the equivalent resistance R dash. So R dash 1 by R dash, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3, that is equals to 1 upon R by 3 plus 1 by R by 3 plus 1 by R by 3. This will be 3 by R, 3 by R, 3 by R, 3 by R plus 3 by R plus 3 by R. This will be, if I take LCM, which is coming out as 369, and R dash will be equals to R by 9. What I have to calculate? I have to calculate the value of R by R dash. So the value of R by was already R, and R dash coming out as R by 9. So the ratio is 9 by 1 or 9 ratio 1. Do I have any answer? 9 by 1. So the option number D will be the right answer in this case. Now the next question says, how would you connect these 3 resistors, each of resistance 4 ohm, so that the combination has a resistance of 6 ohm. Now we are having 3 resistance, each of 4 ohm value. So what are the possibilities so that we get the value as 6 ohm? 1, 2, 3. If I connected in series, so that will be 4 plus 4 plus 4, which is coming out as 12. For the parallel combination, it will be 4 by 3, not possible. So what I have to do, let's consider this. I'm having like 2 resistors in parallel combination, 1 in series combination. Let's put the value as 4 ohm and 4 ohm and this as 4 ohm. If I calculate the equivalent resistance of this parallel 4 ohm and 4 ohm, what will be I getting? Tell me fast. R dash will be coming out as 4 multiply 4 divided by 8 on cancelling 2. So I will be getting 2 ohm. So if this combination is giving 2 ohms, this is 4 ohm, so R equivalent is 6 ohm. So this is the correct method of applying or to connect the 4 ohm resistors so as we can get the equivalent resistance as 6 ohm. Now the next question is, show how you would connect these 3 resistors of 6 ohm so that the combination has a resistance of 9 ohm. Also justify your answer. Again, we have to do the same process. If I'm going to put 2 different resistors in parallel and next one in series, this is 6 ohm, 6 ohm and 6 ohm. On getting this, R dash will be equals to 6 by 2, which will be giving us 3 ohm, and finally the 3 ohm and 6 ohm in series will be giving us 3 plus 6, 9 ohm value. So that will be the final answer. So the one combination in parallel and the other one, the last one, will be connected in series. The next question says, which was asked in 2020, 3 2 ohm resistors ABC are connected in such a way that the total resistance of the combination is 3 ohm. Show the arrangement of 3 resistors. Justify your answer. I think this will be exactly same that we have done so far. If I'm going to connect 2 resistors in parallel and 1 resistor in series. So let's check 2 ohm, 2 ohm and 2 ohm. So this parallel combination will be giving us R by 2, which will be equals to 2 by 2, nothing but 1 ohm, and the equivalent will be 1 ohm and 2 ohm, and R equivalent is coming out as 3 ohm. So yes, this is the combination. This is how we need to connect the resistors. So what are the advantages of parallel over series combination? First of all, we need to understand which one is really helpful. So they're asking about the advantages of connecting the combination or the resistors in parallel. What are the benefits of that? First of all, the independence of appliances. You must have observed in your home, you are having a switchboard where through which you are connecting like individual appliance. If you want to turn on the light only, the light will be turned on. For the fan, you are having separate switch. For any tube light, bulb, table lamp, AC or any other thing, you are having a separate switchboard. So the independency of the one circuit to the another will be completely removed off. What you have to observe that it should not be depend on each other. So the parallel combination will be giving you the liberty that the separate branches will be provided to the different resistors, and this is how you can do the calculation. The second thing is, devices of different types need different current. Sometimes what happens, you are using a tube light as well as an AC. So observe it minutely. The amount of current which is required for the tube light is comparatively very less as compared to the air conditioner, which is consuming the larger amount of current. In that case, so the devices of different type needs different current. So the parallel combination will be giving you that liberty, because if I'm going to connect the very smaller required current value, the tube light or air conditioner, the more amount of current will also flow through the tube light. Maybe it is going to be fused because air conditioner was required more amount of current. Vice versa is also true. Maybe the tube light is working, but the AC cannot take that much of current which was actually required for the air conditioner. Hence, this condition is not favorable for the home appliances or the electric circuit. It also reduces the equivalent resistance. See, the amount of current which is required to flow through any circuit in our home especially. So we are having like 240 volt approximately. That is the nearest measurement of voltage which is provided at the domestic circuit in our home appliances. So they required their own kind of current. In that case, the parallel circuit which is giving us the reduced equivalent resistance, and the total flow of current will be maintained through the complete circuit. So this is another benefit. So we are given with the question, which type of circuit, series or parallel, should be used when you have to operate different electrical gadgets in your house. List 3 reasons for your answers. Now they are asking the same thing, the advantages of parallel combination over series combination. First of all, I am going to use parallel combination. The 3 major reasons it is going to ask. First of all, if one gets fused, others can be operated. In series, if one gets fused, the circuit will be fused completely. Separate switch can be provided. And third, reduces equivalent resistance. So these are the major 3 listed reasons that we can write in the examination as well. Talking about the diagram, what kind of circuit generally you would be able to see when there will be an electric circuit. So for electric circuit, the symbol will be like that we have already mentioned earlier as well. For the battery, the combination of cells you would be able to see. For the plug or switch, if in the circuit a switch is given and it is given like that, that means the circuit is closed. Whereas if the circuit is, if this type of switch is given where there are only kind of bracket and 2 lines are given, that means the circuit is open, the current is not going to flow. Whereas if this kind of symbol being given, that means the circuit is closed, the current is flowing through it. If the wires are joined, that means you will be given with this kind of junction and another wire will be coming out from that particular junction. And if the wire is crossing each other, that means a kind of jumper will be given to you, this curved line, and then the wire will be shown as that it means they are not connected to each other. Electric bulb will be represented by this, resistance will be represented by this, and if rheostat or variable resistor being given, so this is the symbol of variable resistor and this is the symbol of rheostat. Rheostat generally changes the variable value on the desired depending upon the length. So this channel or this arrow representing the kind of movement we are doing on the rheostat, and these are the symbols of ammeter and voltmeter. So the circuit generally comprises of majorly these components, and this is how you would be able to see the electrical circuit. So what do the symbols given below represent in the electric circuit? Write one function of each. So this is nothing but ammeter. It measures current. It measures electric current. Similarly, this is variable resistor. This is variable resistor. It gives variable value of resistor. Variable value of resistor. So these are the functions and representation. We are having another question. It says calculate the values of the following. First of all, the total resistance of the circuit, then total current drawn and the potential difference across parallel combination of 10 and 15 ohm. First of all, we need to calculate the equivalent resistance. We are provided with, if the current is flowing through this, the current will be distributed in I1 and I2 combination, which means they are parallel. Now the current will flow through this, and another part where the current has been distributed in I4 and I3, again combined as I, going towards the negative terminal of the battery. So we are having 2 parallel combinations. One by one we are going to solve for each of them. So one we are having 10 ohm, 15 ohm. So this will be giving us R dash will be equals to R1 R2 over R1 plus R2. So this is 10 multiply 15 divided by 25. So which is coming out as, this is 3, this is 5, this is 2. Finally I am getting 6 ohm. R double dash. For the second one, the circuit is 40 and 60. So this is 60, this is 40, 60 ohm, 40 ohm, and R double dash is equals to R1 R2 by R1 plus R2, 60 multiply 40 divided by 100. On cancelling, I will be getting 6 4s are 24 ohms. Now, instead of this, I am having 6 ohm. This is giving me 6 ohm value and this is giving me 24 ohm value, and now the same amount of current will be flowing through this. So R equivalent will be how much? 6 plus 24, which is coming out as 30 ohm. Now that will be the final equivalent resistance across this circuit. In the second, they are asking the total current drawn from the source. So this was the part number 1. Now in part 2, they're asking about current. So V, according to the Ohm's law, that is V by R. So the potential that is given, that is 15, and equivalent resistance is 30. Finally, the value is 1 by 2, or current value is 0.5 ampere. Now that's how we can calculate the value of current. In the third part, they are asking about the potential difference across the parallel combination of 6 and 15. So the equivalent resistance that we have obtained is 6 ohm. So in part C, they are asking about potential difference that is equal to IR. So the current across this circuit is how much that we have obtained, that is 0.5 or 1 by 2, and the resistance across 10 and 15 parallel combination is 6. On cancelling out, the value of V that is coming out as 3 volt. So these are the answers that we have obtained one by one. If I'm going to mention the R equivalent, that is coming out as 30 ohm. This is 0.5 ampere, and the combination that is giving me 3 volt value. Next question says, which was asked in 2024, draw a schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells, a 5 ohm resistor, 10 ohm resistor, 15 ohm resistors, and a plug key, all connected in series. First of all, we are going to draw this circuit, how it look like. So 1.5 volt cell and 5 ohm resistors. So 5, then 10, then 15. So these are the resistors that I have connected. So this is 5 ohm, this is 10 ohm, this is 15 ohm. So this is 1.5 volt, battery is connected. Now 5, 10 and 15 connected. Now they are asking the electric current passing through the circuit. So to calculate the value, I need to calculate part A. In that case, I can see the equivalent resistance is 5 plus 10 plus 15, which is coming out as 30 ohm. I need to calculate electric current. That means I is equals to V by R. The value of V is 1.5. The value of R is 30. So the current is nothing but 1 by 20 ampere. You can even calculate in terms of decimal, you will be getting 0.05. Now the potential difference across 10 ohm resistor when the plug key is closed. So asking about the potential difference across this one. So V is equals to IR. According to the Ohm's law, I will be applying formula. So potential difference that is equal to current which is flowing through it, that is 1 by 20, and the value of resistor is 10 ohm. On cancelling, I will be getting 1 by 2 or 0.5 volts. So these are the two values that I have obtained, that is 1 by 20 ampere and 0.5 volts. This is how you can solve such kind of questions. Now in this question, we have to draw the schematic diagram. So I will be putting all the values. So we are given with 3 resistors, 5 ohm, 10 ohm, 15 ohm. So this is 5, 10, 15. So I'm writing the value 5 ohm, 10 ohm, 15 ohm. Plug and key connected in series. So I'm connected in series, and we are given with 4 1.5 volt cells. So this is 1, 2, 3 and 4. So all are of 1.5 volt, 1.5 volt, 1.5 volt and 1.5 5 volt. So now if we observe, the total value of potential is 1.5 4 times. So the potential is coming out as 6 volt. According to this question, they're asking about the current passing through the circuit. So I need to calculate the current passing through the circuit. For A, I have to calculate the value of equivalent resistance first of all. So R equivalent is 5 plus 10 plus 15, which is coming out as 30 ohm, and according to formula, I is equals to V by R. So the value of potential is 6, the value of resistance is 30, which is giving me 1 by 5, that is 0.2 ampere. For part B, they are asking about the potential difference across 10 ohm. So I need to calculate potential difference across 10 ohm. So potential difference across 10 ohm, that will be IR 10 ohm. See, for the individual resistor, you have to put only that value. The value of I is 1 by 5 or 0.2. You can put either of them. The value of resistor is 10. So the potential across 10 ohm is 2 volts. So these are the answers. One is 0.2 ampere and 2 volts. This is how we can solve this. Moving to the next question. So now the next part is electrical power. What is electric power? So it says the rate at which the electrical energy is consumed. So you must have noticed in your home, when the appliances are given, it clearly says there is something which is related to the power, because the energy is already being consumed in your home. You are using the electric current in the different appliances. So it clearly mentions that the rate at which electrical energy is consumed, that is called electric power. The formula says power is equals to voltage into current, or the potential difference into electric current, that is P equals to VI. So if we look at this, P is equals to VI. If I'm going to put Ohm's law, so V is equals to IR multiplied by I, which will be giving us I square R. That means the second one, this was the very first formula, second one is I square R. Now from here also, if I'm going to put the value of I as V upon R according to the Ohm's law, the third formula which will be appearing, that is V square by R. So that is depending upon the kind of circuit being given to us, whatever values being given to us, we will apply the formula accordingly. So here the P represents the power, the SI unit is watt, represented by capital W. This is potential difference and electric current, all the SI units, but the unit of power is watt, represented by capital W. So the question generally appears like that, like define the electric power expressed in terms of potential difference and resistance. So in the previous slide, what I have just shown, that is the definition, and this is how the question that you need to write according to this format, and you would be able to complete the question. Now, based on that, we are having a question. Let's have a look. So this says, in the given circuit, calculate the power consumed in watts in the resistor 2 ohm. So in this, we have to calculate the power consumed. What exactly we are given with? We are given with the potential difference, that is 6 volts. Also, we can see that the resistors, both the resistors 1 ohm and 2 ohm are connected in series. So if I calculate the R equivalent, I will be writing R1 plus R2, and finally I will be getting 3 ohm. Why I have done that? So that I can calculate the value of electric current, and accordingly we can pass the electric current through individual resistors. So if I need to calculate the value of I, what exactly I need to do? First of all, the R equivalent I have V, so I will be equals to V by R. So this is 6, this is 3, and 2 ampere is the current which is actually flowing through this circuit. I reached up to this conclusion, which also clearly says, because these two resistors are in series, the 2 ampere current will be flowing through 1 ohm as well as 2 ohm. Now for the 2 ohm, I know the amount of current which is flowing through it, that is 2 ampere. Now I have to calculate the value of power across 2 ohm. So what is the formula? So we have VI, we have I square R and others. So how to proceed with it? To get the value of power across this, what I have to do, so right, power is equals to I square R. So the value of current is 2 square multiply 2, that is 4 times 2, which is coming out as 8 volts. So that will be the final answer for this question. What I did, I just find the amount of current which is flowing through this and I applied P equals to I square R, because the same amount of current is flowing through this. Now the next question which is given to us, which was asked in 2021 and 2022, which says an electric heater rated 1100 watt operates at 220 volt. We need to calculate resistance and current drawn by it. So we need to write the given value. So the value of power that is given as 100 watt, we have provided with the potential difference, that is 220 volt. First of all, we need to calculate the amount of current. The reason is we know the formula for the power, that is equals to VI. So the value given as 11100, V given as 220, and the value of I will be how much? 1100 by 220, 0 and 0 will get cancelled out. If I divide it with 11, so this will be 2 and this will be 10, and finally the value of current which is coming out as 5 ampere. So the first answer that I have already obtained. Now I have to calculate the value of resistance. So as we have already know, V is equals to IR. The value of V that we have already given, that is 220. Current we have already evaluated, that is 5. So the R is equals to 220 by 5. So R equals to, let's cancel this, 4 and 4. So the value of resistor will be 44 ohms. That's how you can solve such questions. Now in the next question, what exactly they have been asked? They are saying that consider two lamps A and B, their power rating is given. So both the resistors or both the appliances having their own power rating. So this one is 1, this is 2. Find the ratio of resistances of two lamps. See, if the power rating is different, that means that there are two different appliances, which also means they are having a separate resistance value for the individual one. If we need to calculate in this manner, so I'm going to write the separate one. For appliance A, we are given with the power, that is 50 watt, and we are given with the potential value, that is 220 volt. For bulb B, or for the appliance B or lamp B, we are having power that is given as 25 watt, and for the potential difference we are given with 220 volt. See, if the resistors are different and we have to calculate the ratio of RA and RB, it's better to use the formula based or related to that. So we know power is equals to V square by R. So in first case, if I find RA, that will be equal to, by doing the cross multiplication, I will be getting V square by P. If I put the value, I will be getting 220 square by the power given is 50. Similarly, for the second one, that is RB, I will be getting V square by P, that will be 220 square by, and this is 25. What I have to calculate? I have to do the ratio RA by RB. Let's do this. RA by RB, that is equal to 220 whole square by 50 divided by 220 whole square by 25. Amazingly, these two are going to cancel out each other. 25 will come in the numerator and 50, and finally the value of RA by RB is coming out as 1 by 2. That will be your final answer. So what you understood? If they are providing us the power rating, the resistance value that we can calculate, and then we can proceed with it. I hope you got it. Now the next question, which is meant for you, which is an electric iron consumes energy at a rate of 880 watt when heating is at a maximum rate and 330 watt when heating is at minimum rate. If the source voltage is 220 volt, calculate the current and resistance in each case. I want you to solve this question and provide me your answers in the comment box. So this is your homework question. Please solve it and share your answers as soon as possible with me, and I'll tell you whether this question is correct or not. Moving ahead to the next one. So now the next question says, if two LED bulbs of 10 watt and 5 watt are connected in series, if the current flowing through 5 watt bulb is 0.05 ampere. So what exactly been given? There are two bulbs, 1, 2. So this is bulb A and bulb B. This is of 10 watt. This is of 5 watt, and it says if the current flowing through 5 watt is 0.005 ampere, the current flowing through 10 watt bulb is, it's already been given, it is in series. If it is in series, then the same amount of current will be flowing through the resistors, both resistors. So the answer is C, that is 0.005 ampere. Now the next thing is electrical energy. Electrical energy is the amount of energy that we are using in the domestic circuit or for the commercial purpose, which says supplied by the cells, and according to the formula, it is energy is equals to power into time. It is generated from the formula that we have studied as per the power is equals to energy by time taken. So it says power is energy by time taken, that means the amount of time required or consumed by the energy for the supply, that is also giving us the value of power. So if we talk about the unit of energy, that is joule, but the energy that is consuming by us at home or in the commercial or domestic purpose, it is represented by kilowatt hour, because the amount of power that we are using monthly, so that is in terms of kilowatt, because kilowatt will give you the, in terms of 1000 watt, and the number of hours you are using that energy. So kilowatt hour will be also known as units. So if we see that 1 unit is equals to 1 kilowatt hour, so you must have heard in your home that the unit consumption is very high. In Delhi region, you must have, like, government has given some amount of units free to the consumers. So this is how the unit means. Bill that is producing, that is the number of units into the price of unit. So the bill which is generating in our home, it is the total amount will be consumed as the number of units, which means kilowatt hour consumption, multiply the price depending on the number of days for which you want to generate the bill. For 1 day it will remain same. For a month, for January month, it will be 31 days, so multiply by 31. Try to find out the consumed energy by all the appliances given at home, and then you can calculate the amount. This is how you can find the amount or the billing cycle of the electrical appliances. Based on that, we are having few questions. Let's have a look what kind of question been asked according to this. So it says for a heater whose rating is 4 kilowatt. So that means we are provided with energy and then 220 volt supply. So kilowatt is the power given to us in the given data, that is kilowatt, and potential that is given to us, that is 220 volt. Now they're asking about the energy consumed in 2 hours. They're asking us about the energy. How to proceed with such questions if they are asking? So we know the formula for energy, that is E is equals to power into time. So energy will be equals to the value of power that is given in kilowatt, that is 4 kilowatt hour, 4 kilowatt. So this is 4 kilowatt, and time, that is 2 hours. So the value of energy is nothing but 8 kilowatt hour. So that will be the value of energy consumed. Now they're saying if 1 kilowatt hour is prices at 4.5 rupees per unit, then the cost of energy consumed. So for part B, we need to calculate cost of energy. So to calculate the cost, what we have to do? Number of units multiply by price. So the number of units consumed, that is 8 kilowatt hour, multiply the price per unit, that is 4.50. On doing the multiplication, we can get the value on 4.50. So that is coming out as 8 5s are 40, 36. I think this will be the value, or this will be the amount of rupees which is required to pay by the consumer, right? In the next question, what they are given, this says in a house, 2 bulbs of 50 watt each are used for 6 hours daily, and electric geyser of 1 kilowatt is used for 1 hour daily. Calculate the total energy consumed in a month for 30 days and its cost at a rate of rupees 8 per kilowatt hour. First of all, we need to calculate the energy consumed by the individual appliances. In that case, if I'm having a bulb 50 watt, so the power of bulb 1, that is given as 50 watt. Talking about its energy, that is 6 hours. It is taking 6 hours. So power into time. So 50 watt multiply time is 6 hours daily, which is coming out as 300 watt hour. And electric geyser, that is of 1 kilowatt hour. I need to convert it into kilowatt hour, so which is coming out as 0.3 kilowatt hour. Talking about geyser, so geyser, already the power is given, that is 1 kilowatt hour, timing 1 hour. So the energy for the geyser, which is coming out as 1 kilowatt multiply 1 hour, which will be 1 kilowatt hour. So this is how we came into some sort of conclusion that we are having these are the energies, but we need to keep this thing in mind. There are 2 bulbs. So if I calculate the total energy consumed, which will be, so 0.3 multiply by 2, and for how many days? 30 days. So multiply by 30 plus this one, that is 1 kilowatt hour, that is consumed for 1, okay, and for 30 days. Let's calculate what is the total amount of energy. So this is coming out as 9, this is 18 plus 30. So the total energy consumed, that is 48 kilowatt hour. This is what I am getting, the total energy consumption. Now I have to calculate cost. For the cost, number of units multiply by price. So the number of units are 48 and the price, that is 8. On multiplication, so this is 4, 6, 32 and 6, that is 38. So the answer is 384 rupees. That's how you can solve such questions. Now the next question says, a rated voltage of an air conditioner is 220 volt. The air conditioner consumes 22 units of electrical energy in 10 hours. So we are given with some values. I'm going to write it. The potential difference of the air conditioner consumed, that is 220 volt. It consumes 22 units of electrical energy. So 22 units, or I can also write it as 22 kilowatt hour, and consumed in 10 hours. So the time given as 10 hours. I have to calculate the power rating of the air conditioner. So if I need to calculate the power rating, so in that case, for the first one, I know the formula, that is E is equals to time. So the E is already given, that is 22 kilowatt hour divided by time consumed, that is 10 hours, that is equals to power. So if I'm going to cancel out, the power is coming out as 2.2 kilowatt. So this is how we can evaluate the power rating. Second thing, they're asking about the current drawn by the air conditioner. So we know the formula, that is power is equals to VI. So the value of P that we have already evaluated, how much? 2.2 kilowatt. 2.2 kilowatt. V, we already know that is 220, and I need to calculate. Because it is given in kilowatt, I need to solve, or I need to convert it into watt only. So this is going to be 2200 divided by 220, that is equals to I, 0 0 will get cancelled out, this will be 10. So I will be equals to 10 ampere. Now the next part, the resistance of the air conditioner. Resistance, to calculate the value of resistance, V will be equals to IR. The V that is given as 220, and the amount of current that we have calculated, that is 10. 0 and 0 will get cancelled out, and the resistance value is coming out as 22 ohms. That's how we can solve such questions, right? Now next we have the heating effect of current. See, one question been asked previously, and that was like, what is the heating effect of current? Express the amount of heat produced by when the current is passing through resistor, or something like that. So this previous year question is actually based on the heating effect of current. One by one we will be discussing about that, what exactly it is. Through a conductor, if an electric current passes and the electric device conductor becomes hot after some time, what we have seen, if you have observed, if there is a bulb and the electric current is passing through it, after some time, if you are going to remove that bulb, if you are going to touch it, you would observe that the bulb will become very, very hot. So that is called the heating effect of current. This phenomena is called heating effect of current. The reason is, when the electrons are passing through the conductor, it will be, the resistance will be offered, and due to the random motion of the electrons, the heat will produce. More the resistance, more heating, the effect will be appeared on that particular appliance. This is how it seems. So according to this diagram, if you see, if the value of resistor is high, the heating effect will also be higher. So we need to consider this thing in mind. We are required the higher value of resistance so as to provide the heating effect. Talking about the Joule's law of heating, which is related to this, which says, on the basis of heating effect, the heat which is actually produced will be directly proportional to the current square, will be directly proportional to the resistance offered by the conductor, and for the amount of time, how much time they have taken to flow the current. So on combining this, we have got this formula, H equals to I square RT. The unit is joules. But what else? H is equals to I square RT. What if I'm going to use I square and I apply the Ohm's law? I will be getting V square by R square multiplied by R into T. So R and R will get cancelled out. So I have got another formula, that is V square by R multiplied by T. That is the another formula to get the value of heating effect or the heat energy. Another thing, how we can else solve this thing. So let's do one thing. For the value of R, let's put another Ohm's law, apply Ohm's law one more time. So this is I square, R will be equals to V upon I into T. So square and I will get cancelled out, and the value of H is again VIT. So that is the third one. So we have got three different formulas. So if we compare from the previous power thing, what we have seen, power was equal to VI. Here we have given the multiplication of T, that is VIT. We have also seen I square R. In power, we have seen I square RT. In power, we were having V square by R. Here in heating effect, we have V square by R into T. So what we have observed, to calculate the heating effect, the formula for the power, if we are multiplying it with the time, then this will be giving us the heating effect of electric current. So in that case, if I need to find out like what kind of questions been appear from this particular topic, so yes, we have done this already. So the question is, a 5 ohm resistor is connected across a battery of 5 volts. So let's write down the given values. So we are given with a conductor or a resistor of value 5 ohm connected across a battery of 6 volts. Calculate the energy that dissipates as a heat in 10 seconds. Now they're talking about the heat energy that dissipates, which means it is actually asking about the heat value. So what kind of value that I need to put to get this? H is equals to V square by R into T. So I'm going to put the formula V square by R multiplied by T. So the V that is given as 6 multiply 6 divided by 5 multiply by 10. On cancelling I will be getting 2 and the value is coming out as 72 joules. This is how we can calculate. We know the formula, we need to only put the values into this. I hope you got it. There are 3 different formulas which we have evaluated also from the power. We related with it with the power formula. Now talking about some practical applications where we have seen the heating effect. So in our home, generally we have seen in the electric iron, which is used for the ironing purpose. So it actually generates heat. Similarly, electric oven, electric kettle, heater. During the winter, you must have observed the heater being used in the various houses. So these are the practical examples of the heating effect. What else? So practical application, that is material used for the heating devices. It must be having high melting point and high resistivity. I am just mentioning it very loud and clear. We are going to use alloys for that, which must be having high resistivity and high melting point. First of all, we need to understand what kind of materials they are. First, like tungsten. If we observe, tungsten is one of them who's having the higher melting point than any other thing, because it is having high resistivity and high melting point. So it generates heat and it emits light. So it is having high melting point. Most of the energy that is appears as heat as only a small part of light based on the heating effect of current. Most of the energy already been used, but some effect can be seen in terms of heat. We need to consider this, like complete energy is not transforming into heat energy, right? What are the safety devices? So based on the heating effect, that is called fuse. Earlier, write down, like these days we are using the miniature circuit breaker, that is called MCB. Right now this is the trend. Previously we were using fuse, and which was actually based on the heating effect of current, where a fuse was used and this wire, which is made up of the high melting point, which was connected in between. So sometimes the voltage fluctuation gives the higher supply of current, which generates the higher heating effect. As a result, the circuit generally gets breakdown and we can replace it later. Actually, it was preventing our household. If the more amount of electric current is actually going to be supplied, or due to short circuiting, if the reverse current is going to flow, the electrical appliances will be definitely going to be fused. So safety, for the safety purpose, electric fuse will be very helpful for us. What else? Fused wire can be made up of the alloy, that is of aluminium, copper, lead and iron. Fused wire would have the high resistivity and high melting point. The rating of fused wire, the maximum amount of current should be flow through it. If high current flows more than required, fuse gets heated and melt. So it is having the rating, defined rating. It's been written on that particular fuse, be it of 1 ampere, 2 ampere, 10 ampere, etc. So such kind of fuse you would be able to see. If you are having an extension cord at your home, there are certain companies which are already providing a fuse at the back or at the side, some with the red cap. You would be able to see a cartridge, a cylindrical cartridge kind of fuse, so that sometimes the electric supply is provided higher, or the higher consumed appliance being connected, like for example like electric iron or some geyser kind of thing. Definitely the fuse is going to get burst. Your extension cord will be safe in that particular case. I hope you get it. Now the question being given, like state the Joule's law of heating, how is this effect useful for the electric circuit where fuse? So I have already explained. This question being asked in 2024, might be appear in the coming examination. There are certain other definitions which has been asked in the previous time in a 1 marker. So what are these? like the SI unit of current, that is 1 ampere. So if we need to define the 1 ampere, what I have to do, first write down the definition. If 1 coulomb of charge through the conductor for 1 second. What does that mean? It means that if I is equals to Q by T, I need to calculate the 1 ampere. So if I need to get 1 ampere, the value of charge should be of 1 value and this should be of 1 second. Then only I will be getting the value as 1 ampere. So in a language, in a writing manner, you can say that when 1 coulomb of charge flowing through the conductor in 1 second, the current flowing through the conductor is known as 1 ampere. Similarly, they're asking about the SI unit of potential difference is 1 volt. So in that case, I will be writing the formula, that is W by Q. So if I need to get the value of 1 volt, I need to be the work, that is 1 joule work to be done on 1 coulomb of charge to move from one place to another, that is called 1 volt. So the potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving a positive charge of 1 coulomb from one point to the another. What else? What is 1 ohm? So when 1 ohm is defined as the resistance of one object when the current of 1 ampere flows through an object, potential difference of 1 volt, which means according to the Ohm's law, the value of R is V upon I. If I need to get 1 ohm, it has to be 1 volt by 1 ampere. So these are the definitions generally appearing in the examination 1 marker that we should be familiar with. Similarly, for the 1 watt power, in that case, what has to be done? I am going to write the formula, that is power equals to potential difference into electric current. So if I need to get 1 watt, which means the 1 volt and 1 ampere value has to be there. Now read out the definition, like 1 watt is the power consumed when 1 ampere of current flows through the circuit on applying a potential difference of 1 volt. The summary of this chapter, what we have come across, we started with charges. Q. Related to that, we came across with electric current because I was equal to Q by T. Then we moved to potential difference because potential difference was separately W by Q, charge was given into that. Then we switched to Ohm's law. In Ohm's law, we came across with V equal to IR. Then we switched to resistance and combination of resistance, where we came across with series and parallel. That was the very first phase of this thing. Then we came up with electric power, then energy, then heating effect or power rating. These are the major topics that we have covered so far, and from the most of the papers, or almost the 99.9% paper will be appearing from this particular topic. What you have to do, you have to solve like all the questions which were solved by me and given in the homework. Write down the answers in the comment box, and for the next chapter we will be meeting again on Friday. So thank you so much for your valuable time for learning. Have a great time. Bye bye.